So what is pi? I'm not talking about the classic American dessert. I'm talking about the mathematical marvel that starts with 3.14159265 and goes on forever. Pi is the ratio of the circumference of a circle to its diameter, and it has proven to be helpful and perplexing to architects and mathematicians alike for over 4,000 years. Before pi was discovered, architects often used trial and error to build circular or spherical structures, such as columns, which resulted in inconsistencies and weaknesses. Records showed the Babylonians using pi for construction as early as 1900 BC. Their initial calculation involved pegs and strings and resulted in an approximation of 3, which was later replaced with 3 1/8, or 3.125. In 1650 BC, the Egyptians approximated pi to be 3.1605, which they used for construction like the Babylonians, and possibly for the Great Pyramids of Giza. Then along came Archimedes of Syracuse, an incredible mathematician, astronomer, and engineer. Around 250 BC, Archimedes used the method of exhaustion to achieve a greater level of precision and calculate the closest approximation of pi for his time. He did this by drawing two similar 96-sided polygons, one inscribed within a circle and one circumscribed around the same circle. By this method, he estimated pi to be between 3 and 1071, approximately 3.1408, and 3 1/7, approximately 3.1429. After Archimedes, a brilliant mathematician named Zhu Chengzi used a similar method to calculate pi as 355 over 113, which is approximately 3.14159292, which is correct to 6 decimal places. To calculate pi to that accuracy using circumscribed and inscribed polygons, he must have started with a regular 24,576-sided polygon and performed very lengthy calculations. Up until the 1600s, pi was still calculated using Archimedes' method of inscribed polygons, but that changed in 1656 when a man named John Wallis established a formula based on 1/2 pi involving the multiplication of an infinite series of fractions. Later that century, Sir Isaac Newton used a binomial theorem to calculate pi to 16 decimal places. By the end of the 18th century, pi had been calculated to over 100 digits using this and similar methods. Progress slowed for the next 200 years until the 20th century when Srinivasa Ramanujan developed a formula for calculating pi based on its reciprocal fraction. This method was later incorporated into computer algorithms. With the invention of more advanced computers, pi grew to new lengths. By 1949, the ENIAC computer calculated pi to 2,037 digits. Then IBM 7090 reached the 100,000th digit of pi in 1961. And in 1973, the CDC 7600 calculated pi to the 1,000,000th decimal place. Currently, a U.S. computer storage company based in California holds the record for the most digits of pi calculated. They calculated pi to 202 trillion decimal places. To put that into perspective, if you type that number in a continuous line at a standard 10-point font, it would reach over 4.4 billion miles, meaning if you extended it out into our solar system, it would pass all of our planets and the dwarf planet Pluto. Even calculated past 202 trillion decimal places, pi has yet to show any sort of pattern and likely never will. Other than being incredibly interesting for being a never-ending number, pi is fascinating because it shows up in all sorts of mathematical formulas and experiments, even when there's not a clear circle present. For example, if you calculate the number of collisions between two blocks, one with a much larger mass than the other, the total number of collisions will approximate the digits of pi. In this example, there's a 10 billion kilogram block and a 1 kilogram block. and the number of collisions is 314,158, which is very close to the first 6 digits of pi, 3.14159. Although hidden, a circle is still present, and thus pi is involved. Another intriguing example of an instance where pi appears is known as Poisson's needles. When needles with length L are randomly dropped on lines 2L apart, the number of needles dropped divided by the needles that intersect the line will approximate pi. The more needles you drop, the closer to pi you get. Because the needles can be dropped at any angle, the possible placement makes a circle, and that is why pi is involved. These are just 2 examples of the hundreds of instances where pi appears. In the words of Dr. Maitreya, whether calculating the vastness of space or understanding the spiral of the DNA, pi is involved.